Alright, this video is for the review of Unit 4. Now, I'm going to say at the outset that this video will probably end up being more than 15 minutes long. So, be warned. Now, for those of you, sorry, let me rephrase that. As you're going through this, if it's a question that you already understand and know, then feel free to skip forward to a question that you don't understand and focus on that time. If you need help with everything, then sit through the entire video. But as I said, if you already understand specific questions, then feel free to skip those questions and just focus on the questions that you don't understand. Okay, so starting with question 1, obviously. It says for triangle XYZ, if measure of angle X is 67, measure of angle Y is 48 degrees, and measure of angle Z is 65 degrees. What is the shortest side of the triangle? Well, easiest way to do this, they don't give us a diagram, is to sketch your diagram. Okay, now I've said this many times in the past, and it still holds true. Your sketch doesn't have to be perfect. Okay, so X, Y, and Z. So X is 67, Y is 48, and Z is 65. Now it's asking for the shortest side. Now remember, the shortest side will always be across from the smallest zoom out it a little bit, the smallest angle. Okay, well, the smallest angle is the 48. So if we draw a line straight out, we hit that side. And so the shortest side is XZ. And so that's our shortest side. Okay, so the shortest side is XZ. Now, for question 2, it says find the length of MN. Sorry, moved it up a little too far. Find the length of MN. So we're looking for this length here. Well, there's a few things we can do here. Okay, I'm going to set the notebook aside because we've got plenty of room here to work. This is a Pythagorean theorem question. So Pythagorean theorem is a squared plus b squared equals c squared. Well, for squares, for as in FOR, because there's only 3 of them, the area is side times side. Okay, so that means they did this times this to get 64, and a side on a square is the same on all sides, and the same here. Side times side gave us this. So they already did. So this was A, and that was A. This was C, and this was C. This is B, and essentially that's B. Well, they did, so 64 equals A squared. 100 equals C squared. Excuse me. So when we do this, we already know that a squared is 64 plus b squared equals 100. So we subtract 64 and b squared is 36. Now we take the square root of each, and so the square root of b squared is just b, square root of 36 is 6. And so the length of mn is 6. Okay. Now for 3, it says, oh, that focus didn't work. Let's try that again. There we go, that's better. So R is this, S is this. Given that RS equals this, find two possible values for Y. Now, we talked about this in class before, so I'm going to go back to my notebook here so that I can sketch this out. So, what we have, this is question 3. Okay, I've got my graph. Okay, now again, it's just a sketch, it doesn't need to be perfect. So I've got -6, 8. So we're going to call that -6, 8. Again, doesn't have to be perfect. Now we know that the other point is 2y. So it's 2, but we don't know where on the y. So this is R, and we know that somewhere that RS somewhere is here. It's somewhere here, sorry. It can be anywhere along 2. So it could be up here, it could be down here. So this shouldn't be 2y. This should be. Okay. Now we know that RS is 10 because it told us that in the question. It said right here, RS equals 10. Now, what we also know is that S, if we connect this, they meet somewhere here. If we this vertical line and this horizontal line, they meet at this point here that we don't know. The only thing we do know is that the x value is 2. So this is essentially 2z. Now, we don't care about z, we just know that the x value is 2. Now, why do we care that that x value is 2? Because now we know that this goes from -6 to 2. So that means we go 1, 2, 3, 4, 5, 6 to get to 0, and 1, 2 to get there. So 6 and 2 is 8. So we've gone 8 spaces that way. So the part we're missing is A. How far up and down? So again, Pythagorean theorem. A squared plus b squared equals c squared. Well, a squared we don't know. B is 8 and c is 10. Well, we don't know a squared, but b is 8, so 8 squared is 64. 10 squared is 100. And hey, how about that? It's just like the other question. So subtract 64 from each side. And so a squared equals 36. Take the square root of each. And so a is 6. Now, excuse me, I'm very sorry. So now, what that tells us is that since a is 6, we know our starting point was 8, because that's where r was. Okay? So we go up 6 from 8. So we do 8 plus 6. So 8 plus 6 is 14. So y could be 14. So this point could be 2, 14. Y could be, so y equals 14 is a possibility. However, the other way this could work is this triangle could have gone down. And RS could have gone this way. So we would have to do minus 6, because 2y could have been here, and so 8 minus 6 is 2, so y could have been 2. And so for 2 possible values of y, 2 and 14. Okay. Now, this isn't necessary to solving the problem. I'm just showing another example. Okay. For every distance, okay, we can make 2 triangles. So if this is 5 and this is 5, we could have made 2 triangles, one that went this way and one that went this way. So whatever this starting point is, so if this was -5, 4, if we found that this distance was, let's say 7, we would add 7 to 4 and subtract 7 from 4. And so y could have, the new, whoa, hold on, I gotta pause. Stupid lights. Okay, sorry about that. Making this video after school, and obviously the lights timed out. Okay, so obviously the new point would have, the new y values could have been 11 or -3. Okay. So you have to go through all this and then add and subtract from our original y value. Okay, number 4. it says find the measure of angle W. Went a little too far again, sorry. Okay, now, there's several ways we can go about this. First, we can use, I would find this angle using the alternate, or sorry, not the alternate, but the exterior angle theorem. Remember, the exterior angle theorem says that this angle plus this angle equals this angle. So 145 equals, I'm going to call this x plus 79. So we subtract 79 from each side. And so 145 minus 79, well, I don't have a calculator handy right now. So 15 minus 9 is 6. 13 minus 7 is 6. So that means this angle is 66. Now, I'm going to find this angle. I'm going to call it y. This angle and this angle form a linear pair. Linear pair means that they add up to 180 degrees. Well, so y plus 160 equals 180. So minus 160. So y is 20. Now I'm going to call this angle z. Well, angle y and angle z are vertical angles. And vertical angles are congruent, so that means angle z is 20 degrees. And so now we have this angle, this angle, this angle, and this angle all add up to 180. So that means that 180 equals W plus 19 plus 66 plus 20. Well, so that's 180 is W plus 19 plus 66 is, that's 86, so 85 plus 20 is 105. Subtract 105. And so 75 is W. So the measure of angle W is 75 degrees. So you have to take it in parts. We have defined this angle, this, and this angle, and this angle in order to find this angle. Okay? So even though it was only asking for W, we still had to find 3 other angles in order to do it. Okay? We could have found this one, and then in order to find this one, and we could have used the fact that these are a linear pair, and then used the fact that these 3 add up to 180 in order to find this one, and that would have been fine, but we still would have had to do the supplement. This is a linear pair, and then vertical angles to get that. Okay, so number 5. Determine if the 2 angles are congruent, and if so, state the congruence conjecture that supports it. So they tell us that this side is congruent to this side. That's what these little dash marks mean. Now the picture is a little hard to see, so zoom in for it. So the dash marks, there we go. Now, they tell us that these are right angles. So that means they are congruent. Then we can see that this are vertical angles, that these are vertical angles. So we have angle, side, angle. So yes, they are congruent by angle, side, angle. Sorry, it's off the screen. Okay, that's all there is to this one. Now remember, these first 8 questions are all multiple choice. Okay, so this is all you're gonna have to, you'll have to do is find the one that says yes and by angle, side, angle. There'll be distractors in here, so you'll see angle, probably see angle, angle, side, side, angle, side, etc. But you'll have to recognize that this is angle, angle, side, or angle, side, angle rather. But as long as you can recognize which one it is, you'll be good. Okay, number 6. Two triangles have side length of 12 and 25. It says which inequality represents the possible lengths of a third side. Well, so for that, I'm going to come down here. I might be able to fit it in here since we're running that, since you can't fit both on the same screen at the same time. Okay, so we have two sides of a triangle, right? And this should be right and inequality. Again, it'll be multiple choice on the test, but that's why it says which, but So we do 12 plus 25 is 37, and we do 25 minus 12, and we get 13. And so we write our inequality. 13 is less than x is less than 37. That's the inequality, that's it. 13 is smaller than x is smaller than 37. Okay, that's it. Anything in between would work. All right. So you subtract the biggest minus the smallest for the smaller number, and you add the two of them together. If you did 25 plus 12, commutative property, you get the same answer. In the figure below, A, D, B, and G are collinear. So that just means, if you remember when the first unit we talked about, that means they're all on the same line. So CAD measures 63 degrees. BCD, so BCD, that's this smaller one, measures 38 degrees. And CBG, that's this outside one, measures 137 degrees. It wants to know ACD, so this little one. Okay, well, there are a couple ways to do this. There's the long way and the short way. The long way is use this as a linear pair to find this angle, then use the fact that all the angles in the triangle add up to 180 to find this one. Use this as a linear pair to find this one. Then use the fact that all the angles add up to 180 to find this one. The shorter way, I'm going to call this Y. We do the exterior angle theorem. 137 is equal to Y plus 38. These two angles add up to 137. So we subtract 38 from each side. Well, 137 minus 38 is 99. And so then that means that this angle is 99 degrees. Now, this angle is an exterior angle to this triangle. So we use the exterior angle again. This time it'll be 99 equals x plus 63. So we subtract 63. And 9 minus 3 is 6. 9 minus 6 is 3. And so the degree measure of that is 36 degrees. And now another proof-based question. Based on the given information, what can you conclude? Well, this particular one should look very familiar. We did this in our Do Now on Tuesday. We are given the angle, the side, and so what can we conclude? Well, angle, side, angle, and so that would be triangle HIJ is congruent to triangle LJK by angle, side, angle. Okay, and now this last one is just like the free response, and it says write a flowchart proof. I haven't shown you how to write a flowchart proof because, well, flowchart proofs are essentially useless. They only work if you are given absolutely everything you need in your givens. Okay? You know, a flowchart proof essentially only works if you're told everything from the start, and so you can say, because everything was given to me, here's the answer. So they don't really work well. So it says write a flowchart proof, so we're not going to do that. You're going to stick with what we've been doing. Okay, so it says, you know, prove triangle ADB is congruent to angle AEC. Okay, well, so we start like we always do. Statements, reasons, number one, AD is congruent to AE. And her reason, it was given. Number two, AB is congruent to AC. And the reason is it was given. Okay, hold on a second. Okay, the lights keep going out, so I'm just turning the light on this thing. Okay. Now, I'm going to mark off what we've got. AD, AE. So, right there, AD, AE. AB, AC. Now, it wants us to show, lost my other pen. Where did my other pen go? There it is. It wants us to show ADB and AEC. Well, we can't show that until we show the two triangles. So let's show triangle ADB and AEC. So right here we have vertical angles. So we can say angle DAB is congruent to angle EAC, and the reason is vertical angles. Now we have side angle side, so we can say triangle DAB is congruent to triangle EAC by side angle side. And so our last step now is our proof statement. Angle ADB is congruent to angle AEC, and that's by the nice complicated thing of corresponding parts of congruent triangles are congruent. And so we just put CPCTC. That's a C. And that's everything. Now I know it's a long video, and I'm sorry it took so long, but as I said at the beginning, hopefully you skipped the parts you already knew and just focused on the parts you needed. Good luck on your test tomorrow. Hopefully you don't need it. I'm sure you'll do great.